Assalamualaikum everyone. Today we're going to continue on chapter 2.2, three-phase AC circuit. Alright, so you have learned so far from the previous chapter about electrical power system in a single phase. So today in this chapter, you're going to learn about electrical power system, okay, for three-phase generators. Okay, you know that in the three-phase power system, okay, we have a generation part, we have a transmission, and also we have a distribution. So in this part, you know that at the generation side, we have a generator which supply, okay, because this is now a three-phase, okay, so we have a three-phase load. Okay, for this chapter, we're just going to learn about balanced three-phase load. What it means by balance is the loads are all identical. So means that the loads at each of the phase are the same. Okay, so means that, okay, for example, some of the loads can be a small motor, or it can be anything that consume power. Okay, all right, in the balanced three-phase system, the power are delivered instantaneously, okay, to the load. So it remains constant all the time. So it means that, okay, three-phase system needs fewer wires for the power transmission, okay, less wire, and we require smaller generator and also motor size for the same power rating as single-phase system. So that's why in industry, we prefer three-phase system compared to the single-phase system because it delivers more power, okay, with the less wire. Previously, you have learned about single phase. For example, here, okay, the voltage. This is a waveform, a sine wave for a single phase. So in a three-phase system, you will get a voltage, but now you have phase A, and you have phase B, and also phase C. So each of these three phases, they are 120 degrees displaced. Okay, so we're going to see example. Okay, so example. Again, I'm taking voltage as an example. Okay, you have phase A. Okay, that is VA. And then you have, okay, 120 degree displace. You have VB. Okay, it's 120 degree displace between VA and VB, yeah. And then you have VC. Okay, that is the third phase. Okay, so if I want to draw the phasor diagram, so this is the phasor diagram. It's called phasor diagram. So if I say this is VA, sorry, that is VB, that is VC. So you can see that in the balanced load, they are 120 degrees displaced. This just apply for a balanced load. Okay, so if I draw the circuit, or the circuit of a three-phase will look like this. Okay. Alright, this is the supply. Okay, VA, VB, and VC, the one that I drawn here. Okay, so this is phase 1, this is phase 2, and this is phase 3. Okay, then we have load, or L load. Oops, sorry. This is R, L. Because it is a balance, so all the load is identical. Okay, so because this is a balanced three-phase system, so you will see that, okay, the loads are identical. Okay, so this is balanced. What is unbalanced? Unbalanced load. Okay, we're going to have a look. So for example, okay, this again three-phase system, again with VA, VB, and VC. Okay, in unbalanced load, you will see that this is my RL, this is my R. Sorry, my drawing is not really neat. Okay, alright, so you will see that in phase A is just R. Okay, but phase B and C is RL. Okay, so can you see it's not the same? So this is called unbalanced. Okay, but in this chapter we are not going to discuss about unbalanced load. Okay, we're just going to focus on the balanced three-phase system. Okay, so here you will see that, all right, so this is the three-phase Y to Y configuration. Okay, in this side you will see is the supply side, whereas EA, EB, EC is the supply voltage. Alright, then in the middle here we have a transmission line, and then at the end here we have the load. Remember, the load is anything that consumes power. Okay, and we have a neutral point. So N is the neutral point for the load, and O is the neutral point for the supply. Okay, and all are connected in the balanced three-phase load. Okay, so we're going to see, all right, so how we can simplify this circuit into a more simplified form. Okay, so on the left side is exactly the same as the circuit on the right, but instead we simplified it by redrawing it. Okay, so now if you see that this part is the EAO, this is EAB, the supplies. Okay, and if you see here it's connected. Okay, the neutral point is here. Okay, so here again the neutral point is N here. Okay, so the impedance of the load is this part. Okay, this is R, L, and then we're going to call this impedance as ZD. Okay, so this one. Okay, right. So if you see, what I'm going to do next is I'm going to break this circuit into three parts. Okay, the first part I'm going to call it, okay, generator or supply. Okay, it can be called supply as well. Okay, and then this part I'm going to call it transmission. And this part here I'm going to call it load. Okay, so if you see here, okay, there's a current, so we're going to label that as IAN for phase A. This is IBN for phase B. This is ICN for phase C. Okay, so that's all that I'm gonna talk about for now, and we're gonna continue on the next slide in the next video.